Hello everybody, I hope you're doing well. Uh, Welcome to my channel. Today we're going to work on PowerMill from Autodesk. We will work on the 2024 version. So today we will work on a workpiece that we can find directly in PowerMill called Cowling. So to find this workpiece, we'll go to File, then Import, then Example. You can also find this workpiece on the description. So we search for colon, then we will click on it, we will open it, we will find directly our workpiece here. Then we will start by creating a block with a coordinate system in a global transform. Created, accepted, we will create a tool. It will be better if we create a tip reduced tool with a diameter of 16 and the length of 18. It gives us directly 18, but we can put it at 15. We can add a shank directly, and we can add the holder or holders, if we can say that. We'll put a bigger diameter with a 13 diameter and an overhang, bigger overhang, something like 17. We'll add a holder with 63, and that is our tool. We will close. We will create a toolpath. We'll find it in 3D area clearance. We'll at model area clearance. Then there is 4 types of model area clearance. We have raster, we have offset model, we have offset all, and vortex. For with using vortex, we can take big step overs and big step downs to go more quickly with using trochoidals. But in this example, we use offset all because we have, we can say, 3 major regions. So we will see what we will have. We will let as it is the step over, but we will let also thickness as it is. We just choose here spiral and add a step cut in. We will calculate it. We will find that we have a problem that is a plunge in the material. So what will we do? We will create a lead-ins. We will recalculate and put a ramp of 3 degrees here and accept it and calculate. So we will have ramps. We'll do ramping. So we will see how is this toolpath, and to simulate it, we will just simulate it from the start. We'll put uh, as we see here is the simulation, And we have the progression bar here of the simulation and the percentage. So that is now we will do the second toolpath, that is model rest area clearance. We will find it directly in the 3D area clearance. Then we will click here and accept it. The specificity uh, with this toolpath, that is, we have rest here. That is a rest machining, so we must choose the last toolpath as a reference to do this machining. So we'll choose the first one that we did, and we can play with these parameters, but we will let them as they was in the last parameters, because with PowerMill it will always take the last parameters. We will calculate. We have an error here because there is no valid uh, material, because we didn't modify the thickness, so we will put a lower thickness of 0.5, for example, or 0.3. That would be better. So we will calculate. So now I wish that we will have no problem. So as I told you, there was no problem. So I will we will see the simulation, and here is what we will have. The green lines are the machining, the pink ones are the links, and the blue ones are the leadings, uh, leading ones. Then now we will create a finishing toolpath, and we will see uh, what will be done. For finishing toolpaths, we will find them here. We will find them here, and there is different types, but we can choose between optimized Z finishing and constant Z finishing, but I will prefer optimized Z finishing because we have curves here. So we will let it, we will put a thickness of 0 and a small step over to 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 have a big precision, and put it also here. Tolerance, we will let it here as it is, and thickness of 0.0, so we have directly our 3D model. So we will choose smoothing and close it off, or we can remove this. We will, yes, but to have a bare surface, and a bare smoothens, we have to take a small ball-nosed tool. So we'll create it. This is the tool that we will use for finishing. So to change the tool, it is easy with PowerMill. That's the advantage. We can go directly here and calculate it. And we have single development, and here is the toolpath. We'll double click to activate it, then we play the simulation and we will see it. The finishing toolpath will just work on the surface, as we can see it here. This machine takes so much time, we can control the speed in here. To see directly the result of machining without simulation, we can create a stock model. Here we can create it by clicking this and accept. Then we will just select all these tool paths and put them here, then calculate. Then we will just double click on the last step and we will see the finished tool, the finished workpiece. We can choose another drawing options. We have shaded, for example, and it will be like this for this. We can also simulate this. We will close stock model. We can simulate this with activating the material and see what will happen. We can simulate the second one. This will be the workpiece after the second toolpath. Then we can simulate this. Uh, this is the workpiece after the machining. We can close the toolpath and we will have this workpiece done as this, and here it is. After simulation, to exit from view mill, we can exit it from here. And to create the NC program, we can create it here. We'll choose the post processor here. It is here. We can choose the sample one Fainek from directly from Autodesk. We can choose where we can put our uh, our program. We can name it A, for example, and apply. And before we can put the tooling number, we can put it in automatic because we didn't put the tooling number, so we have to put it in automatic. So we apply and accept. Then after this, we have to select all these toolpaths. Then we will drag them in the NC program. Then we press on the right. If we don't have a problem, we will have directly a program. As we can see it here, it is post-processed. Then we can open in an external program, so it is here. Now, the machining, we can find all the steps, and here is how it presents with the post-pro. Thank you for watching my first video. You will find the program, this programming for this process programming for PowerMill